students, today we will see the expression for output response of second order underdamped system. When I am saying underdamped, so we know that range of zeta should be within 0 to 1. Okay. Then one important thing, we are calculating output response for unit step input. Okay. We know that when we are considering unit step input, so R of S will be 1 by S. So what we need to do, when the output response is asked, so we need to calculate C of t. Okay. Now we know the procedure to get C of t. First we need to get transfer function, that is C of S upon R of S. You will substitute the value of R of S in that transfer function, you will get C of S. Then you have to take Laplace inverse so that you will get C of t. Okay. So I hope you know the concept to get C of t. But how we are calculating for standard test or standard second order system. Okay. Now look at this. Here actually C of S upon R of S, this expression we have seen in last lecture. Okay, I will repeat again. C of S upon R of S, I told you to remember this transfer function. Omega n square upon S square plus 2 zeta omega n S plus omega n square. Okay, so this is our standard transfer function for the underdamped system. Okay. Now here we need to calculate output response for unit step input. So what we will do, we will substitute R of S is equal to 1 by S in this transfer function. Okay. So we got C of S as this one because I have substituted R of S is equal to 1. Look at this. Okay. Now our task will start. Okay. Once you will get C of S, now we have to do all that things to get C of t. Okay. So we will rearrange the transfer function in such a way that it will be easy to get Laplace inverse. Okay. For that you should be familiar and you should know how to take Laplace inverse of such systems. Okay. For that you need to remember all that basic formulas. Okay. So look at this. Here I have substituted, and for getting the Laplace inverse I have to rearrange this transfer function in partial fraction form. So for getting partial fraction form, look at this. Here I have replaced this S square plus 2 zeta omega n S plus omega n square by this term. Okay. Just to get simpler equation or transfer function I have replaced. Look at this. Here I have substituted this value S plus zeta omega n the whole square plus omega n square in bracket 1 minus zeta square. You can cross check. Okay. You will get the same answer. If you will solve this, you will get the same answer. But this is to arrange in partial fraction form. Now see here. Here actually I have replaced and I have rearranged in this form. So C of S, I got this term. Look at this. Actually I know the formula for omega d. We have seen omega d is equal to omega n under root of 1 minus zeta square. Look at this. Omega d is equal to omega n under root of 1 minus zeta square. So once you will get omega n square in bracket 1 minus zeta square, so that is nothing but omega d square. So we have substituted with omega d. Okay. Now we got C of S. Then I have rearranged this C of S in partial fraction form. So this is partial fraction form, and you know how to calculate the values of constant. So as this is second order, okay, or quadratic equation. So I have written here Bs plus C. We know that if quadratic equation is there, so we have to rearrange partial fraction form like this. Okay. So this is partial fraction form. Here I have not shown any calculation because you know how to calculate the values of constant from partial fraction form. So see, after calculating we got answer as A is equal to 1, B is equal to minus 1, C is equal to minus 2 zeta omega n. Okay. So what we need to do, we are doing all these things to get Laplace inverse. Okay. So look at this now. Here I got C of S and I have substituted the values of A, B, C. I have substituted A, B, C in this equation and I got this equation as, look at this, I got this equation as this one. Okay. So here I have substituted, you can check here A, B, C I have substituted. Okay. So let's see, C of S is equal to 1 by S minus. Here minus of minus term is there, so this will be plus 2 zeta omega n. Okay, so this is the form I got. Okay, now look at this. Here I have rearranged this 2 zeta omega n as zeta omega n, zeta omega n. Okay, again I am saying why I am doing such thing, because I have to take Laplace inverse. Okay, so here I have splitted this 2 zeta omega n as zeta omega n, zeta omega n. Okay, and the denominator is same. Now next, again I have rearranged C of s as, look at this, 1 by s is as it is. Here s plus zeta omega n upon this denominator plus zeta omega n, look at this, zeta omega n upon this denominator. Okay, but here I have introduced one more term as omega d, because omega d will get cancelled here. You can check here. Here zeta omega n upon only denominator part is there. But here I have introduced one more term as omega d, because I know that omega d is nothing but omega n under root of 1 minus zeta square. So this will get cancelled. So I have introduced the term omega d, omega d. Okay. Now let's see. We will take Laplace inverse. For taking Laplace inverse, we must know the formula. So what is formula? Look at this. I have shown here, or I have written that formula. Laplace inverse of, this is in the form of s plus a upon, look at this, s plus a upon s plus a the whole square plus b square. So when you will take Laplace inverse of this is nothing but e to the power minus at cos bt. So here after taking Laplace inverse, you will get e to the power minus at cos bt. What is a? A is nothing but zeta omega n. What is b? B is nothing but omega d. Okay. Now see, this is the term which I have introduced here, but here we know that Laplace inverse of b upon s plus a square plus b square is equal to e to the power minus at sin bt. Okay, here we have the term s plus a, so this is cos bt. Here we have constant term, so this is sin bt. Okay, now I hope you are getting why I have rearranged, because I have to take Laplace inverse. Now look at this. Here I have taken Laplace inverse, so 1 by Laplace inverse of 1 by s is 1, okay, minus, okay, e to the power, this first term after taking Laplace, e to the power minus zeta omega nt cos bt. So what is b? B is nothing but omega d. So cos omega dt plus, look at this. Here this term is zeta omega n upon omega d. It will be as it is. This term is nothing but b upon, look at this, b upon s plus a square plus b square. Now I hope you got the concept, because this b is there and there should be the term b in the numerator. So I have introduced the term b here. What is b? B is omega d. Okay. So see, zeta omega n upon omega d, it will be as it is, and Laplace inverse of this will be e to the power minus zeta omega nt sin omega bt. Okay. Now see, I have taken Laplace inverse, but I need a simple form of output equation so that we can remember that output equation and we can solve the numerical. So what I did here, look at this, 1 minus e to the power minus zeta omega nt, okay, and here actually what I did, I have replaced this omega d with omega n under root of 1 minus zeta square. Look at this, omega n under root of 1 minus zeta square. Here I have not shown one step here, I have directly written, but I will explain that term also. Cos omega dt plus zeta omega n upon omega d, I have replaced this omega d with this term, and this is nothing but sin omega dt. Okay, see here e to the power minus zeta omega nt, and here there is a term e to the power minus zeta omega nt. So I have taken out this common term e to the power minus zeta omega nt. So what will be left? Cos omega dt plus zeta omega n. I have substituted this omega d with omega n under root of 1 minus zeta square, and this term will be as it is. Okay. So what I did here, I have to reduce that equation. So I am using this zeta triangle. What is that zeta triangle? Look at this. This is actually phi. Okay. This adjacent side is denoted with zeta. Opposite side is denoted with under root of 1 minus zeta square, and hypotenuse is 1. So we know that cos zeta, that is adjacent side. Okay. Cos zeta will be, cos phi will be zeta. Okay. and sine phi, it will be under root of 1 minus zeta square. So what I did, now I am replacing that term with this one. Look at this. Here I have directly written, but for taking this under root of 1 minus zeta square common, okay, what I did here, I have taken or I have multiplied this term with under root of 1 minus zeta square. So see here actually 1 minus e to the power minus zeta omega n t upon under root of 1 minus zeta square. Okay, here it will get multiplied with under root of 1 minus zeta square. Okay, so here there will be term before that. In second step, next step, I have not written here, that will be under root of 1 minus zeta square upon cos omega t, and here there will be the term 1 minus zeta square in the denominator. Okay, and this term will get cancelled. Okay, this omega n will get cancelled, and this term will get cancelled because I have written under root of 1 minus zeta square here. Now look at this, what I did here, I have again written c of t as 1 minus e to the power minus zeta omega n t upon under root of 1 minus zeta square. I hope you got this concept. I have taken out. Then under root of 1 minus zeta square, what is that? Under root of 1 minus zeta square, that is nothing but sine phi. So this term will be sine phi. Okay, so you can replace this under root of 1 minus zeta square with sine phi. And this, what is zeta? Zeta is nothing but cos phi. Okay, so when you will take sine a plus b, this will be in the form of, look at this, this will be in the form of sine phi cos omega dt plus cos phi sine omega dt. Again I am repeating, this will be in the form of sine phi plus sine phi into cos omega dt plus cos phi into sine omega dt. So this is in the form of sine a plus b. This will be in the form of sine a plus b. So I have written here sine a plus b here. Okay. So this is final expression for c of t. So you have to remember this equation also for calculating the value of c of t. Okay, generally the numericals will be based on this formula, and from this output equation we have to calculate different time response parameters. So again I am repeating what you need to remember. You need to remember this output response for second order system. You need to remember this transfer function. You need to remember this characteristic equation. Again this formula is important. You have to remember this zeta triangle also. Okay, because all these things will help you in solving numericals. Okay, see generally the derivation is asked. Question will be derive the output response of second order underdamped system for unit step input. So I hope you got the expression for output response. Thank you students.